Hello everyone, I'm Frank. Welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum. And there's a lot of really smart people there. So what they think might be easy might not be easy for you or me. Sometimes, like, I've had ones where I did not think they were easy, but other people on the forum thought they were. Anyways, today's puzzle is called P Ramen Noodle by Ridwan. And here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and box. The sum of the values of cells on green lines connecting two circles is equal to the concatenation of the two values in the circle in some order. So, for an example, we're going to use this one. For example, e.g., exempli grati, 3, 3, 4, 5, 6, and 1, 3, 4, 5, 6. Oh, we already had a 6. We just accidentally pressed the 3. And 1 is valid, as 3, 4, 6 adds up to 13, which is a concatenation of 1 and 3. So therefore, this is a valid split P line because specifically these three digits, the digits between the circles, add up to a concatenation, which is basically just sticking the two digits together of the two digits that are in the circles. And that would be 1 and 3, which is 13. So that's how split P lines work. That's why we got the P's here. I don't know where we have the ramen noodle. I guess the red band are the ramen noodles. Okay. Digits on a purple line must form a consecutive, non-repeating digits in any order. I think it's supposed to form a set of consecutive, non-repeating digits in any order. Yeah, so this is a Renban line. So this purple or pinkish color. I usually say pink, but some people say purple. Some people say magenta. Pink is easier to say, so that's why I say pink. But the digits on this pink, purple, magenta, whatever color you like line must form a set of consecutive, non-repeating digits in any order. So, for example, if this were to be, say this was a 1, that means in the rest of the line, you would have to have a 2 and a 3, because 1 is only consecutive with 2, which is only consecutive with 1 or 3, and we already have the 1, so the next number must be 3, right? So 1, 2, and 3 are consecutive, and they do not have repeats. That's not important in this puzzle because we don't have a way to make repeats in this puzzle. But in other puzzles, you'll sometimes have Renban lines that go outside cages and that go to different lines, and they still, for a typical Renban, a normal Renban line, you cannot have repeats. So that's Renban line. Digits along an arrow must sum to the digit on that arrow's circle. So, for example, if these two digits must add up to what that digit is, these two digits must add up to what that digit is, and these two digits must add up to what that digit is. So a valid example for here would be, for example, 3, 5, and 8. These two digits add up to what 8 is, right? 3 and 5 adds up to 8. And that's how arrows work. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So, in a Renban of 5 length, you always have a 5 there, right? Because it's either 1, 2, 3, 4, 5, 2, 3, 4, 5, 6, 3, 4, 5, 6, 7, 4, 5, 6, 7, 8, or 5, 6, 7, 8, 9. Notice they all have a 5 in it, no matter what. So therefore, this has to have a 5. These 4 digits must add up to a 2-digit number. You cannot have 1, 2, 3, and 4 here. So therefore, 5, 6, 7, 8, 9 is ruled out. Right? If you have 1, 2, 3, 4, that would only be 10. And 0 can never be a digit in a normal Sudoku. So this cannot have 1 through 4. Therefore, this cannot be 5 through 9. So you can never have a 9 on the Renban then, which means the 9 has to be on this split P line. Yeah, split P line, essentially. What else do we know? We know we have 3 digits adding up to another digit. Therefore, the minimum there would be 1 plus 2 plus 3. Therefore, the minimum there would have to be 6, which means the others have to be 7, 8, or 9. Same here then. This is 6, 7, 8, or 9. If this were 6 with 1, 2, or 3, the problem is you don't have a set of Renban that would actually work, right? You would have at most 3 digits together, which would be 4, 5, 6, and then 7, 8, or 9, which would be consecutive, but that doesn't work, right? Because you need 4 digits that are consecutive. So that doesn't work here. So this cannot be 6 because it can't be 1, 2, 3. If it's 7 and 1, 2, 4, because 7 has to be added up specifically from 1, 2, and 4 if they're all unique. So therefore, you would have 7, 1, 2, 4. Again, you don't have 4 consecutive digits, right? So if you try it, you can't have 3 because 3 is not consecutive. 2 and 4 are no longer allowed because you have 1, 2, and 4. You can't have 5 because 5 is only consecutive with 6, and then you can't go down to 4, and you can't go up to 7. And 8 and 9 are consecutive with each other, but they can't go down to 7. So therefore, 7 doesn't work here either. What about 8? If we have 8, it could be either 1, 2, 5 or 1, 3, 4. If we have 8 and 1, 2, 5, that does not work. Because 6 and 7, 3 and 4 are the only 2 that are consecutive with each other, and they can't go down to 2 or can't go up to 5. 6 and 7 are only consecutive with each other, but it can't go down to 5 and it can't go up to 8. What about 1, 3, 4 with 8? I don't think that works either, right? 2 obviously is separate from itself. 5 can go to 6 and 7, but then the 8 is already taken, so that's not 4 consecutive. Yes, so you can't have 8. Therefore, this must be 9. And if you have 9, we know... So try to have 1, 2, 6. 1, 2, 6 doesn't work because 7, 8 are split from 3, 4, and 5. Therefore, you don't have 4 consecutive there. So cannot be 1, 2, 6. What about 1, 3, 5? If you have 1, 3, 5, you have 6, 7, 8, which is separate from 2 and 4. So 1, 3, 5 doesn't work. Therefore, this must be 2, 3, and 4 here then. Which means this has to be 5, 6, 7, 8 to be consecutive Renban. Therefore, this has to be 1. This could be 1 as a tens digit, so it could be any of the teens or 12. Or it could be 21, but we're not sure. Okay. This has 5 digits at least that are it's greater than, right? Because these 2 must add up to this, and these 2 must add up to this. So these are all smaller than this circle. So this is at least 5. This has to be 1 through 6. It cannot be 2, 3, 4, because if this is 2, 3, 4, this would have to be 2, 3, and 4. There would be 2 cells here that are from 2, 3, or 4. This would be 2 cells from 2, 3, or 4. So we have 4 digits, which require the digits 2, 3, and 4. But that's only 3 digits in that set. So therefore, they can't fill out all 4 cells. So this cannot be 2, 3, and 4 specifically. But it still could become some combination like 1, 3, 4 or 2, 3, 1. That would work. Or 1, 2, 4. We do know 1 has to be... Okay, so say 1 was on this Renban. So 1 can never be on this set, right? 1 can't be here. So say 1 was on this Renban. If this Renban had a 1, it would have to also contain a 2, which would mean the minimum of this arrow would have to be 3 plus 4 plus 5, which adds up to 12, which is not a digit. So therefore, 1 cannot be on this Renban. 1 has to be on the arrow. If you have 2, it's the same problem there. Well, but the thing is, the 2 could be here. So, okay, never mind. We just know from the 1, it can't be there. So this could be 1, 2, this still could be 1, 2, 3, 1, 2, 4. Interesting. 9 is either here or 9 is on the Renban. If 9 is here, this is 1, 2, 6 or 1, 3, 5. If 9 is on the Renban, it's with 8, so therefore this is 6 and 7, and it would be 1, 2, 3 or 1, 2, 4. Huh. Interesting. Okay, I don't know if that helps us any. Oh, one thing I see. These two squares must sum up to what that is. These two squares must sum up to what this is. What's the most this could... Actually, that doesn't make any sense. Well, okay. That means this is an even... These 4 cells must add up to what these 2 cells are, right? Therefore, these are equal to essentially this. So this has to be a 2 times some number. So therefore, it's an even number, which means this has to be odd. But the problem is it could be 21. It cannot be 41. So this can never be 4, 6, or 8 here. Because if this is 4, 6, or 8, that would mean this would have to be 14, 16, or 18. And therefore, this would be odd. Sorry, this would be even. But then we know this is even, and therefore this would be an even number plus an even number, which adds up to an odd number, which is not allowed. That doesn't work, right? An even number plus an even number is always an even number. So therefore, and 45 is odd. So therefore, this cannot be 4, 6, or 8. It could be 2. It can't be 1, obviously. It could be 3, 5, or 7 then. This is 2, 3, 5, or 7. It could be 21, or it's 13, 15, or 17. Therefore, we know this is odd, right? These are consecutive, so this must be odd too. Hold up. This doesn't have to be even. Okay. These are the same as this one, right? These 3 must add up to what this is. So therefore, these 3 and this are the same. So this is 2 times some number. So it's even. This has to be consecutive. So therefore, it's odd. Well, you have an even plus an odd. That makes an odd number for the sum of these 6 cells. Therefore, if you have an odd number and you add an odd number, that would make an even. So this cannot be odd in here. Very clever. I like this. This is very, very cool. This cannot be odd then. So this has to be even to actually make this work, right? Because we know this is even because these 3 add up to this number. So it's 2x something. These are consecutive, so you have to have an odd or an even adding up together, right? So therefore it's odd. So since this is even and this is odd, this 6 cells must be an odd digit, odd number. Now, all 9 cells is 45. So 45 is an odd. Subtract an odd from an odd, you get an even. So these 3 cells must be even. And because it must be even, it must be 12, because it can never be 13, 51, 71, 17, 13, 15. It has to be 12. And therefore, this is 21, because this one has to be odd, and it has to be the other way around. So therefore, this is 21. That was very clever. I like that a lot, actually. So this adds up to 12 here. Now the question is, can this ever be 2 then? Because 2 can no longer be here and 2 can't be here. If this is 2, it would have to be consecutive with 1 or 3. But we know 1 is here, so this would have to be 2 and 3. But if this is 2 and 3, the minimum for this arrow must be 1, 4, and 5, which adds up to 10, which is not a digit. So 2 cannot be here either. So this is 1 and 2 here. Now it could be 1, 2, 3. It could be 2, 3, 4. Sorry, 1, 2, 4. It could be 1, 2, 5 or 1, 2, 6. So those all still work. But this adds up to 12. We know that for certain. So therefore, and the minimum has to be 3, 4, and 5, which adds up to 12. So this has to be the minimum then. It has to be 3, 4, and 5, which means this can't be 3, 4, 5. So this is 1, 2, and 6, which adds up to 9. And therefore, this is 7 and 8. So this can't be 7 and 8 because we have a 7, 8 pair in column 2. And therefore, this has to be a 5, 6 pair in column 2. So that means 5 and 6 cannot be in the rest of the column. So therefore, this is 1, 2, 3, 4, and 9. But 2 obviously can't be here because that must be a 2. This can't be 1 because it must be next to a 2, but the 2 is already taken, so this can't be 1. This can't be, we have a 5, 6, 5, 6 pair in box 7. So this can't be 5. The rest of the box cannot contain 5 or 6. So this is 7, 8, 7, 8. This must be 6 with 7 or 8. So the 6 has to be here. This is 21. So it's either 4, 8, 9, but this can't be 9. It's 5, 7, 9, or it's 6, 7, 8. Therefore, well, we don't know. We don't know what this is. Okay. So this is 1 or 2. These 4 digits, what do these 4 digits add up to? It could be at most 30, but again, 0 can't be a digit. And it adds up to a 2-digit number here, right? So 30 is the most you can have because it'd be 6, 7, 8, and 9, and those are 4 unique digits. That adds up to 30, but therefore you can't have 30 here. So you could have at most 29, because 0 can't be a digit here. So therefore it's at most 29. So therefore, and it's a 2-digit number. So we know there has to be either a 1 or 2 there. We have 1, so one of these cells is a 1 or 2. This cell is a 1 or 2. Therefore, we have 2 cells in row 6 that cannot be that have to be a 1 or 2. So the rest of the row cannot contain a 1 or 2. Therefore, this is a 6, so this can't be 6, and this is 1 or 2. And this is 1 or 2. So the rest of the row cannot contain 1 or 2, so it's 3, 4, 5, 7, 8, or 9. Okay. Pretty cool. This still could be 3 because it could be 1 and 2. What else do we have? So 1 or 2 is here. This can only add up to this is only 3 digits, and it has to add up to at most 24. So it could be 24, 23 are possible. We're not sure though. Okay, so what are the possibilities for this? This cannot be 1, 2, 3, 4, 5, because if this were 1, 2, 3, 4, 5, this would add up to 30. And there is no 0 allowed in normal Sudoku. So this cannot be 1, which means the 1 has to be one of these 4 also. So we know this is at least 10. 2. So 4 through 8 actually works, because then this adds up to 15, and that's fine. So this could be 1 and 5. That's fine. So 4 through 8 works. What about 3 through 7? If you have 3 through 7, that would mean this is 1, 2, 8, and 9, which would add up to 20. So 3 through 7 does not work. So we know 1 through 5 doesn't work, 5 through 9 doesn't work, and 3 through 7 doesn't work. What about 2 through 6? If this is 2 through 6, this has to be 7, 8, and 9, and 1. So that does work, but that's 2 and 5. So, but we know then this is 5 either way. So we have, yeah, and therefore this could be 2 through 6, or it could be 4 through 8. Right? So this is either, what are the possibilities? This is 1, 2, 3, and 9 to go with 4 through 8. So this is 4, 5, 6, 7, 8. Or this is 1, 6, 1, 7, 8, 9. And either way, the 1 has to be in one of these 4 cells, so therefore the 1 has to be one of here. Therefore, 1 has to be one of these 3. So this could be 2 or 3 also. Okay, let's just remove, okay, let's just do this. Let's remove these. So we know 4, 5, and 6 have to be, well, okay, we know 4, 5, and 6 have to be here. One of the ones have to be here. This can't be 9. One of these is 9. This, oh yeah, we have a 1, 2, 5 triplet now in row 6. So the rest of the row cannot contain 1, 2, or 5. And it can't contain a 6 also. So this can't be 5, and there can't be a 6 here. Okay. What do we have here then? Okay, so 3 can be consecutive with 4. 4 can be consecutive with 3 or 5. And 9 can be consecutive with 8. So those are all valid. Okay. So 1 is one of these two. So this has to be either... This would also have to be 15 or 25. But 3 digits, unique digits, cannot add up to 225, right? Because the most you can have is 7, 8, and 9, so that's 24. Therefore, this must be 15. So this has to be 15, which means this is 1, 2, 3, and 9. Therefore, this can't be 1. This has to be 4, 5, 6, 7, 8. This can't be 1 anymore, therefore this is 2, which forces this to be 1. So this can't be 2 anymore. So this is 3 or 4. This is fine. 9 is one of these 4. We don't have very much information here. So these 3 add up to 15. And it cannot obviously be 51 or 52. So I just ignored that. So it adds up to 15 without a 1 and without a 5. So it could be 2, 4, 9. What else can it be? 2, 6, 7. If it's 3, that means 2 digits adding up to 12, so it's 3, 4, 8. And then 4 cannot be with any that does not have 2 or 3. So 1 has to be one of these two. So this could be 249 again. So obviously 9 can't be here. It could be 267. Or it's 348. That's a lot of possibilities. That's basically all, yeah. But we know it's one of those 3 sets. That's all. Okay. What else do we know? We know these 3 digits must add up to these 2. Concatenate together. So there's either a 1 or 2 here. Or both. You could actually have both. Yeah, that could work actually. 3, 4, 5, and 1, 2 works fine. Oh. These 2 digits must add up to this one. These 2 digits must add up to this one. Therefore, this is essentially 3 times this number. So 45 is 0 mod 3. This number is 3x, so it's also 0 mod 3, which means this number is also 0 mod 3, because that's a what is the word? That's a can't remember the term. Quality. That's a quality of digits that are divisible by 3. So anytime you have any digit that's divisible by 3, that's 0 mod 3, if you take... Well, actually, I think that's actually just remainder theory. So anytime you have anything that's 0 mod 3 and you subtract out another 0 mod 3 from it, you must get a 0 mod 3. So therefore, this is 0 mod 3. And, okay, the quality is that if you have a unique number, if you have a number and it's divisible by 3, the sum of the digits that concatenate together must add up to 3. So we know these 2 digits then must add up to 3. Because these digits add up to 3. And since these digits add up to 3, these digits must add up to 3. Right? Because it's a concatenation of 2 digits that add up to 3. The sum adds up to 3. Sum multiple 3. Sorry. It has to be 0 mod 3. The sum of the digits, of any digits that's divisible by 3, must add up to the sum, must add up to a sum that is also 0 mod 3. And mod is basically just divide by 3 and what's the remainder. So 0 mod 3, since this must be 3 times something, 45 is 3 times 15, so 45 is divisible by 3. And this number is divisible by 3. Therefore, this number must be divisible by 3. Therefore, these 2 digits added together must be divisible by 3. Therefore, since those 2 digits are the same, are divisible by 3, the sum of anything, even if it's swapped or whatever, must be divisible by 3, right? If this were 12, even if this were 21 or whatever, that's divisible by 3. So these 2 are divisible by 3. These 3 are divisible by 3. Therefore, these 4 must be divisible by 3. And we know it's a consecutive set. So the only sets that work that way then cannot be 1 through 4, because 1, 2, 3, and 4 is not divisible by 3. Neither is 2, 3, 4, 5. But 3, 4, 5, 6, and 6, 7, 8, 9 are divisible by 3. Because 7 and 8 add up to a number that's divisible by 3. 6 is divisible by 3. 9 is divisible by 3. Same thing with 4 and 5. 4 and 5 add up to 9, which is divisible by 3. And both 3 and 6 are divisible by 3. Therefore, the whole sum is divisible by 3. So you have to have a 6 here. And it's either with 3, 4, 5, or it's with 7, 8, and 9. So this is 3, 4, 5, 6, with 7, 8, or 9. Sorry, it's 3, 4, 5, 6, or it's 6, 7, 8, 9. Now, if this were 3, 4, 5, 6, you would have to have these 3 digits add up to something that's divisible by 3, and these 2 digits add up to something divisible by 3. You obviously cannot have 7, 8, and 9 added together, so therefore this would have to be either 7, 8, and 9 with 1, 2 out of 7, 8, or 9 with 1, or 2 out of 7, 8, and 9 with 2. But either way, they would have to both be divisible by 3. If you had 1, 8, and 9, unfortunately, that adds up to 18. So that's not possible to have this be 18 here. Oh, in fact, actually, interesting. Yeah, we have a 1 we know has to be in column 8 and 9. We also have a 1 in row 6 that has to be in 8 or 9, column 8 or 9. Therefore, in column 8 or 9, you cannot have any 1s. Therefore, the 1 has to be one of these 3. Can you ever have a 2 here, essentially, is the question. Yes, if it's 1 and 2, and this is 3, 4, 5. But that's it, I think. You can't have a 20x, right? You could have 2, 7, and 9 adding up to 18. So that does work. So this would be 2, 7, and 9. Obviously, this couldn't be 2. And this would have to be 1 and 8, if that's the case. So this could be 3, 4, 5, 6. That actually does work. And then this would be 2, 7, or 9. So that's the only one that works with 3, 4, 5, 6. What about the ones that work with 6, 7, 8, 9? You can have at most 3, 4, and 5, and that adds up to 12, which is the minimum for a 2-digit number. So this would then have to be 3, 4, 5, which makes that a 2. Okay. That could work. So if this were 1, 8, this would be 18 then also. Okay, so if this were 1 and 8, this has to also be 18. Because it can't be 81. 4 digits, unique digits don't add up to 81. So this would be 18, which would mean this 3x would have to be 45 minus 18. 45 minus 18, I think, is 9, right? Or 27, which would have to be divided by 3, which makes 9. So then this would be 9, if that's the case, right? 9 times 3 is 27, plus 18 is 45. Yep, okay. If this is 21, assume this was 21 instead of 12. If it's 21, actually, let's try 12. If this was 12, this adds up to 12. This 3x would have to add up to 45 minus 12, which is 33. So x would have to be 11, which is not possible. So this could not be 12. But this could be 21, though. And if this is 21, this adds up to 21. 45 minus 21 is 24. So this would then have to be 8. Huh. Interesting. Right? So this has to be 8 or 9. Interesting. So this would then count as 21. This would be 12, obviously. So this would be 3, 4, 5. That seems fine. One can never be here. One is always in one of these two cells. That doesn't really tell us very much. If this is 6, 7, 8, 9, this would have to be 12. This would be 3, 4, 5. This would then be 21 for these 4 cells. Since this is 21, these would add up to 24, so this would have to be 8. So anytime this is 6, 7, 8, 9, the 8 cannot be here, because this would have to be 8. So 8 has to be one of these two or one of these two. We're not sure which. Okay. What else do we know? Not sure. If this is 18, what does that mean this is? I don't think that really helps much. What if this is 3, 4, 5, 6? Then this is 18. This is 2 set. Okay, so this cannot be 9 ever. Because if this is 9, this would have to be 3, 4, 5, 6, which forces this to be 18, which means this is 18, which means this is 27, which means this is a 9. So this can never be 9. Oh. Right, so if this is not 9 here, this has to be... So if this is not 9 in this one, this has to be 279 here. Which means... Okay, so actually another thing that we have is where's the 9 in column 7? Cannot be here, cannot be here, so it has to be one of these two in... in box 6 or column 7. If this is 9 here, that means this is 2 and 1, so this is 21, which would force this to be 8. This would have to be 6, 7, 8, 9. This would be 8, this would be 6 or 7. So this would have to have a 9 here, which means 9 could not be here. In addition, if this is not 9, this is 279, and this has to be 18, which makes that 18. This is 9, which eliminates 9 from being here. So this can't be 9. So this can never be 9 here. So the 9 has to be one of these two. We're not sure which. Oh, interesting. Hmm. Hmm. Okay, if this is 279, that means this is 18, which means this is 18, which means this is 9. That's fine. Okay, if this is 6, 7, 8, 9 here, that means this is 12, and this is 3, 4, 5. So this becomes 6, 7, 9. This is 2 and 1, so this is 21, which forces this to be 24, which makes that an 8. So then this can't be 8, and this can't be 9. Which means this has to be 9, and the 9 would have to be here. Right? So if this is 6, 7, 8, 9, this can't be 9, actually. Right? Because we knew this was 21, or this is 1 and 2. This would have to be 21, therefore this is 8, which eliminates 8 from being here. This is 6, 7, this is 6, 7, or 9, so therefore the 9 has to be here. And therefore this couldn't be 8, so that can't be 9, so therefore this is 9, which would force the 9 to be here. So 9 is one of these 3 digits. Um, oh, actually, how does that work? So assume this was 6, 7, 8, 9, right? This would be 2 and 1. So this is 3, 4, 5. That adds up to 12. But this could not be 12 because then this would have to add up to 33, which would mean that digit is at 11, which is not possible. So this has to be 21. Therefore, this is 21, which makes this add up to 24, which means that's an 8. But, oh, I guess it could be. Right. So for 8, this does not have a 6, 7, or 9 allowed. And it can't be, obviously, can't be anything with 8. So this would have to be 3, 5 in that instance. Which would mean that this is, oh, we have a problem. Where is then the 2? This can't be 2 because this is 21, obviously. And this can't be 2. And this can't be 2 because 2 and 6 would add up to 8, but we already have the 6 accounted for. So therefore, this cannot be 2 here. This can't be 12. Therefore, this must be 3, 4, 5, and 6. Which means this has to be 2, 7, and 9. This can't be 9, obviously. This has to be 18. Since this is 18, this can only add up to 18. So therefore, this adds up to 27, which means this has to be a 9. So this is a 9 now. It cannot be 2 and 7, because that would eliminate all possibilities here. It could be 1, 8. It could be 3, 6, or it could be 4, 5. But the thing is, where is a 2 in row 1? It cannot be here. It can't be here. It can't be any of these. Therefore, it must be here. So this is 2, which means this can't be 2. This is 7, 9, 7, 9. So 9 cannot be here. 7 can't be here. So therefore, the 9 has to be one of these two. We know 5 is one of these two cells. 5 has to be one of these 4 cells in columns 8 and 9. So we have both 5s in columns 8 and 9 here and here. Therefore, the rest of the column, 8 and 9, cannot have a 5. So this can't be 5. And this can't, we already know that can't be 7. This is 18. This has to be 1, 8. This could be 2, 7, 3, 6, or 4, 5. We just don't know which. Okay, so where is the 7 now in row 1? Can't be any of these, can't be here, can't be any of these two. Because this can't be 7 because it has to be next to an 8, if that's the case. Therefore, this is the 7. So since this is 7, this can't be 7, therefore that's 8, which makes that can't be 8, so this is 7. This can't be 7 or 8, so this must be 6. So this can no longer be 6, and it can't be 3 then, correspondingly. Oh, this can't have a 9. So this must add up to 21, remember, and it can't have a 9. So therefore, this has to be 6, 7, 8. Since this is 6, 7, 8, these can't be 7 or 8. The 9 cannot be on the arrows, so therefore the 9 has to be one of these two. And we have a 3, 4, 9 triplet now in row 6. So the rest of the row cannot contain 3, 4, or 9, and it can't be 6 here. So this is 7, 8, and this is 7 or 8. So this cannot be 9. Therefore, the 9 has to be here, because the 9 has to be in column 8 here and column 9 here. Can't be here because of this 9. The 9 has to be one of these two because we have a 3, 4, 9 triplet, because this can't be 6, 7, or 8. Therefore, this has to be the 9. Therefore, these two must add up to 6 to add up to 15. And the only possibility now is 2 and 4. 2 and 4 there. Okay. So this cannot be 6, 7, or 8. So that eliminates 1, 8, 2, 7, and 3, 6. So therefore, this has to be 4 and 5. Therefore, this is 1, 2, and 3 because we have a 6, 7, 8 triplet and a 4, 5 pair, which eliminates 4, 5, 6, 7, 8 from the rest of the column. Therefore, this is 1, 2, 3. This can't be 1. Therefore, this is 1. This can't be 2 because it would have to be next to a 3 on the run band. So therefore, this is a 3, this is a 2, which makes this 3. This can't be 2 or 3. This is 9. This can't be 3 or 9 then. So this is a 1, 2 pair. This can't be 1, obviously, anymore. So 3 has to be consecutive with 4. So this is a 4. This can no longer be 4. Again, this can't be 4 and 5. Could be 1, 8. Could be 3, 6. We're not sure which. We know we have a 2 here. This can't be 3 anymore. So this has to have a 3 here. And this has to be 3 here. Therefore, none of these can be 3s. Therefore, this has to be a 3. There's no other place. This can't be 8. This must be 7, which forces this to be 8, which means it can't be 8. So it's a 6, 7 pair. This can't be 7 or 8, so it's 4, 5, and 6, which means these must be 7 or 8 because we have a 4, 5, 6 triplet in box 9, so the rest of the box cannot contain 4, 5, or 6. Therefore, this is 8, and this is 7. This can't be 8. Neither of these can be 8. Therefore, the 8 has to be here, which means this has to be a 6. So this can't be 6. So it's 4, 5. This is 8. This is 8. So this can't be 4. Therefore, it must be 3. This can't be 3 or 4. So this must be 2. This can't be 2 or 3. So this must be 4. So 3 cannot be here. This is a 1, 4, 9 triplet. Therefore, the rest of the column, or rest of the box, cannot contain 1, 4, 9. So it must be 3, 5, or 8. This is 3, 5, or 8. This is 3, 5, or 8. We can delete the 9s because we know 1, 4, or 9 has to be there. Okay, this cannot be 3. This must have 3 consecutive numbers. So it's either 5, 6, 7, 6, 7, 8, or 7, 8, 9. Either way, 7 has to be here, and it can only be in this spot. So this is 7. This can't be 7, so therefore the 7 has to be one of these two. This can't be 6 anymore. This can't be 4. So this has to be 5 or 6. So this could be 5 or 6, or it could be 8. Those are the only possibilities. Therefore, 6 has to be here. 9 can't be here. 9 can't be here. Therefore, this must be a 9. So this cannot be 9. This has to be 3. And therefore, to have 2 digits add up to it, it has to be 1 and 2. So this can't be 1 or 2. This has to be... This 3 forces this to be 4, which forces this to be 9. So this has to be 4 and 5. Since this is 4 and 5, we have a 4, 5, 4, 5 pair in column 6. The rest of the column cannot contain a 4 or 5. Therefore, this is 6. This can't be 5 or 6. This must be 8. So this is 5. These can't be 5 or 4. So this is 6, which makes this 4. This can't be 6. So this is 5. This is 6. This has to be 5 then. 2 can no longer be here. Therefore, the 2 has to be here. This can't be 6 anymore. Therefore, this is 7, which makes that 6. This can't be 8. This is 7. Therefore, it's 8. The 2 is here, which means this can't be 2. So this is 4. This is 2. This can't be 2. So this is 1. This is 2. This can't be 1. So this is 5. This is 1. This can't be 5. So this is 4. There is no 4 here. Okay. This can't be 4, so this has to be 5, which means this can't be 4, 5. So this is 3. This can't be 4, so this is 5. Therefore, that's a 4. This can no longer be 8, which means this can't be 1, because this would have to add up to 9. So this can't be 1. This can't be 3, so this can't add up to 6. So this is 1 or 3. This is 1 or 3. And this has to be 6, 7, or 8. Right. So all the 2's are done. This can no longer be 4, so this has to be 1. So this can't be 1, so this has to be 3, which adds up with 6 to add up to 9. Therefore, this is 7, 8. This can't be 3, therefore that makes that 1, which makes this 8, which makes that 1. This can't be 8 anymore, so this is 7, this is 8, that makes that 9, and that's 7. Let's see, this can't be 3 or 6, so this is 5, which makes that 3, which makes this 6. This can't be 5 or 3, so this is 8. 8 is only next to 9, so therefore that's a 9. This can't be 8 or 3, so this is 5. Can't be 5 or 8, so this is 3. This can't be 1 or 9, so this is 4. This can't be 4, so this is 5, and therefore this is a 4. And that's a solution. Yeah, pretty straightforward, actually. Not too bad. It just took me a while to get there, actually, I guess. Very clever use. I loved this part, especially. This part was awesome, where you realized it had to be odd on one side and even on the other side. And the only possibility then would have to be 1 and 2, because you can't have 41 add up to 3 digits, unique digits. Fun puzzle, and I hope you had a fun time during this solve, and I'll see you next time on Frank Puzzles. Take care.